Hello, good morning, students. How are you all? I can see Pradyuman Lama, then Shreya Singh. I can see those who are joining. Yeah. Raksha Chetri, Arpita Paul. I can see them. Come on, first, join first so that we can start our class. Okay. So I can see, hello, Kushi Agarwal. Good morning. And Anand Mangalam Garg also I can see. Chang Tamang. Okay. Today I'll take the attendance. Because I can see very few are there and maximum of you are not attending. So that's why the attendance will be taken today. So that's why I decided to take the attendance also. Today the attendance will be taken. Yeah. Very few are attending the class. Very few are there. Why Senbin is writing his name like 15 times? What's the reason? Senbin is writing his name for 15 times. What's the reason? I do not know. Okay. Senbin wants to say that he is present, sir. Don't say you are present. When I'll call your name, that time you have to say that you are present. Okay. That time you have to write your name. When I'll call your name, that time you have to write your name. And that will indicate that you are present. Okay. Understood. So now you are writing that you are present. It's not for Senmin, it's for all. Now you are writing that you are present, and but when I'm calling your name, that time you are not there. Means you are absent. Okay. Understood? Fine. I can see very few are there. And this week, just a minute. You have got your new class timetable. I'm sure that you have got your new class timetable. So okay. So your physics class is on today and tomorrow. Okay, today and tomorrow. Understood? Means Monday and Tuesday. not tomorrow, next Tuesday. Okay, next Tuesday you will have your CP. Okay, CP, you will have your CP. So and the syllabus of CP is this chapter what we are doing now, the same chapter what we are doing through these live classes, the same is the syllabus for your CP. Understood? So what is the date of CP? That is, yes, not tomorrow, the next Tuesday. Okay, next Tuesday you will have your CP. Okay, let me take out the what is the date next week, next Tuesday. Let me see. The date is, yes, today is 17th, 18th, 25, 25th August. 25th August. 25th August. Okay, 25th August, CP1 Physics. Understood? And what is the syllabus? Syllabus is the chapter which is going on. Okay, chapter which is going on. Okay, so I hope you understood. 25th. Yeah, Somako is writing, okay, sir, CP1 or 2. This is CP1. I have written in the comment also, you can see. 25th August, I have written in the comment. 25th August, CP1 Physics, chapter which is going on. The chapter work and energy is going on. So we will do work and energy in CP1. Okay, in CP1. Understood? And the syllabus I told you. Okay, I told you the syllabus. So whatever we are discussing, listen to me, all of you listen to me. It's very clear to, I want to make it very clear that whatever we are discussing in the class, okay, in this live class, whatever we are discussing, whatever we have discussed in our live class and what we are going to discuss in our live class, future live classes, you will learn only those things. Okay, you will learn only and only those things. Listen, students, I want to say you something that few things, few extra things also we are doing, which is not there in your book. I want to tell you, in our future, in our previous class, we discussed a numerical that listen to me nicely. In in our previous class, we discussed a numerical. If you remember that. Um, the velocity of a scooty is say 25 km per hour. Now you increase the velocity. Now the speed was 25 km per hour. Now the speed is 50 km per hour. Okay, first it was 25, now it is 50. So speed is increased. How much work is done? How much energy is spent? Okay, or what is the kinetic energy spent? So all these answers are same. So this thing means half mv square minus half mv u square. This one you will not get in your physics book, but it's there. It's there. Why it's there? Because we have already done in the class. Am I clear? So that's why it's just an example. So something you will not get in your textbook, what I'm teaching, something you will not get in your textbook. This is some extra things I'm teaching you, some extra things which are not there in your textbook, but these are there in the syllabus. Okay, since we are discussing in the class, so the same thing will be there in the CP or in the unit test or in your half yearly exam. Fine, all these things will be there. Fine, it's not that it's not there in the book, so we will not do it. No, since we have discussed in the class, so it's there. Fine. Now, Today, like in our previous classes, we discussed about what is work, what is power, what is energy, their unit, work unit, power unit, energy unit, all these units and definition we discussed. After that, we discussed about potential energy. We discussed numericals based on potential energy. After that, we discussed kinetic energy, and the kinetic energy's numerical also we discussed. No, kinetic energy numericals also we discussed, and we discussed that also, that the velocity of a car is changing from, means it's increasing. The velocity of a car is increasing or decreasing. So what is the amount of work done, or what is the amount of energy spent? We have discussed all this. Yes, we have discussed all this. Today we will see a simple pendulum, and then we'll see the potential energy and the kinetic energy of a simple pendulum. Understood? You know simple pendulum? I've got a simple pendulum. Just a minute. This is a simple pendulum. Can you see? It's a simple pendulum. See, simple pendulum. Okay, this is a simple pendulum. Understood? Okay, this is called bob. Okay, this is called bob. Okay, and this is the string, and this is the bob. This is not called ball, though this is looking like a ball, but this is called bob. Okay, this is simple pendulum. See, okay, this is simple pendulum. Understood? So now, so when this is, this position is called, this position is called mean position. Understood? This position is called mean position. But when your bob is going here, this is called extreme position. See, extreme position. So this is called extreme position, this is called extreme position, but this is called mean position. All of you try to understand it. This is mean position. Okay, extreme position, extreme position. Okay, extreme position, extreme position, and this is called mean position. Understood? Try to understand. Extreme position, extreme position, and this is called mean position. Okay, so when an object is going like this, so what I told you, I want to repeat it again. I want to repeat it again, that see, this is mean position and this is extreme position. This is also called extreme position. Extreme position, extreme position, and this is mean position. Okay, so when an object is going like this, okay, when an object is going like this, means when the object is in mean extreme position, its velocity is 0. When the object is in extreme position, extreme position and extreme position, the velocity is 0. And the when the object is in mean position, the velocity is maximum. Understood? So when the object is here, the velocity is 0. When the object is here, the velocity is 0. But when the object is in mean position, the velocity is maximum, like this. Okay, like this. Okay, so when the object is here, that is extreme position, the velocity is 0. When it is here, the velocity is 0. But when it is here, the mean position, the velocity is maximum. Okay, like this. Okay, one more thing. When the object is in mean position, height is 0. Okay, height is 0. But when it is extreme position, height is there, maximum height. Here also maximum height. When the object is at extreme position, height is maximum. When the object is in mean position, height is 0. I repeat, when the object is in extreme position, when the object is in, try to understand this fact, this is very very important, this is very very important. When the pendulum is in extreme position and extreme position, when it is in extreme position, then maximum height but zero velocity. Understood? When the bob is in extreme position, extreme, then velocity is zero but height is maximum. Don't forget this. And when the object is in mean position, then velocity is maximum, height is zero. Okay, so don't forget this, what I told you, that this is the pendulum. Okay, extreme position, and this is also called extreme position. Okay, extreme position, this is also called extreme position. At extreme position, the velocity is zero but height is maximum. At mean position, this is called mean position. At mean position, the velocity is maximum but height is zero. Okay, understood? At extreme position, velocity is zero but height is maximum. Understood this? Now, whatever we have discussed, okay, Khushi Agarwal is saying that extreme position, velocity is zero, height maximum, correct. And mean position means height is zero, velocity is maximum. Understood, all of you? So, whatever we have discussed, we will draw it now in our copy. Okay, let's draw it. Whatever we discussed, the same will draw now. Let me draw, after that you will draw. Okay, all of you draw it. All of you draw this figure. This figure. This is A, B, and this is M. This you write M, M position, and this is A and B position. All of you draw it. Okay, so as I told you that extreme position, this position is extreme position and this is also extreme position. Fine. So at extreme positions, the velocity is zero. Okay, so you have done this, drawn. This is M, this is mean position, that's why M, and this is A, this is B. Okay, now right, A and B, A and B are extreme position. A and B are extreme position. Full stop. At extreme position, at extreme positions, the velocity of the velocity is zero. The velocity is zero. The velocity is zero. But but height covered is maximum. But height covered is maximum. Okay. Next line you write. Next paragraph. Write in the next paragraph. M is the mean position. M is the mean position. Okay. M is the mean position. Full stop. Full stop. At mean position, the velocity of the pendulum is maximum. At mean position, the velocity of the pendulum is maximum. Maximum. Okay. And height covered is 0. Okay. Height covered is 0. Fine. Now, in the next line you write, in the next paragraph, okay, next paragraph you write, at extreme positions, at extreme positions, at extreme positions, potential energy equal to mgh. Like this, potential energy equal to mgh. Okay, potential energy equal to mgh. Kinetic energy equal to half m v square equal to half m 0 square. Half m 0 square, because velocity is 0, so kinetic energy is 0. Do this. At extreme position, potential energy equal to mgh. Potential energy equal to mgh. Kinetic energy equal to half m v square, that is half m 0 square. Okay, v means 0 square. So 0 into something is always 0. So that's why kinetic energy is 0. Okay. Fine. So you understood, at extreme positions, when the pendulum was here and the pendulum was here. Okay. Understood? Pendulum was here and pendulum was here. Extreme positions, the kinetic energy is 0. Why kinetic energy is 0? Because I told you, in extreme positions, velocity is 0. If the velocity is 0, so half mv square, so velocity is 0, so that is 0. Yes. So kinetic energy is 0. So I hope you have done this. Potential energy equal to mgh, kinetic energy equal to half m v square. V is 0, so half m 0 square, that is 0 kinetic energy. Okay. Next paragraph you write. Next paragraph. At mean position, potential energy equal to mgh, equal to mg0. Because I told you, at mean position height is 0. Check it, you have written it. At mean position position, potential energy is 0. Why? Height is 0. Okay. And potential energy is mgh. We know that. And kinetic energy equal to half mv square. Okay. This one in mean position. Write it. All of you write it. This is in mean position. In mean position, potential energy equal to mgh. So mg 0, that is 0. Kinetic energy equal to half mv square. So this is the value. Okay. Try to understand. Fine. So we have seen that. Now concentrate what I'm saying. Just concentrate it. See, this is the pendulum. Okay. This is extreme position. Extreme position. But this is mean position. Understood? Extreme position. Extreme position. But this is mean position. So in extreme position, kinetic energy is 0, but potential energy maximum. Here, the kinetic energy maximum, potential energy 0. Okay. Now, another information for you. At mean position, total energy means kinetic plus potential. Understood? This is mean position. In mean position, total energy means kinetic plus potential. So you will get the total kinetic energy, potential plus kinetic. And at extreme position, again total energy, kinetic plus potential. Okay. You know what? Here total energy, here total energy will be same. Understood? So total energy in mean position equal to total energy in extreme position. Fine. I repeat, total energy in extreme positions, total energy in mean position. Total energy means, yes, potential energy plus kinetic energy. Understood this? Total energy at mean position equal to total energy at extreme position. Fine. So I can write that in the next line you write, in the next line. Okay, I'm writing it. After that you write potential energy plus kinetic energy at extreme equal to potential energy plus kinetic energy at mean. Write like this. This sentence you write. Okay. So potential energy plus kinetic energy at extreme position equal to potential energy plus kinetic energy at mean position. Understood? So potential energy plus kinetic energy means total energy. Total energy at mean, total energy at extreme position. Understood this? Now, in the next line you write, Khushi Agarwal is writing total energy potential plus kinetic at mean equal to total energy potential plus kinetic at extreme position. Very good. Correct. So, we saw that potential energy plus kinetic energy at mean position equal to potential energy plus kinetic energy at extreme position. Fine. Don't forget this. Now, in the next line you write, so total energy is conserved. So total energy is conserved. Total energy is conserved. 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 Total energy is conserved. This is known as, write it. This is known as, this is known as this is known as conservation law of energy. Conservation law of energy. This is known as conservation law of energy. Okay. So if I ask you in exam, that state the law of conservation of energy for a simple pendulum, you have to show me all this. Understood? State the law of conservation of energy of a simple pendulum. You have to tell me all this. Understood? Fine. So total energy is conserved. This is known as conservation law of energy. Yes, Anand Mangalam, correct. So total energy is conserved. This is known as conservation law of energy. Fine. Yes. Now from this equation, now we will continue with this equation. See, what can we do from this equation? See, extreme position. You all of you see your equation. This answer is done. This answer is done. Now we'll continue this equation. See how. First of all, you see in your equation, first what is there? Potential plus kinetic at extreme position. We know that in extreme position, kinetic energy is 0. Kinetic energy is 0. So we'll put 0 here. We'll put 0 here. Okay. So we'll get potential plus 0 at extreme. That means potential plus 0 means potential. So potential energy at extreme. Okay. So if you put 0 here, potential energy plus 0 at extreme equal to 0 plus, but in mean position potential energy is 0. No, in mean position potential energy is 0. So 0 plus kinetic energy at mean position. So potential energy at extreme, what we are getting, equal to kinetic energy at mean. Say, by continue this equation, at extreme position, potential energy is there, kinetic energy is 0. But at mean position, potential energy is 0, kinetic energy is there. So potential plus 0, that is potential energy at max extreme. Potential energy at extreme equal to kinetic energy at mean position. So kinetic energy at mean position equal to potential energy at extreme. So remember this relation. Potential energy at extreme equal to kinetic energy at mean. It's a formula. You have to remember this formula. Okay. Potential energy at extreme equal to kinetic energy at mean. Understood? So what is the main formula we have got? Potential energy, this is the pendulum, extreme position. That means potential energy at extreme position equal to kinetic energy at mean position. Understood? Potential energy at extreme position equal to kinetic energy at mean position. Fine. So this is the formula. You have to remember this formula. Understood? Now, All of you have done this? Fine. What he's writing, Somanko Bhattacharya, sir, any extreme position? Yeah, extreme position. Extreme position is one, any extreme position, yes. This is taken out. See, I have to repair it. Wait, I have to repair it. Done. Yes, any extreme position. This extreme position or this extreme position. Yes. Okay. This extreme position and this extreme position. Okay. Any extreme position. So, total energy at extreme position equal to total energy at mean position. That means potential energy at extreme position and kinetic energy at mean position. This is the formula. You have to remember this. We'll do the numerical. Now. Just a second. Just a minute. Now, just a minute, all of you. Yeah. If you comment one time, that's enough for me. I can read all the comments. All the comments are displaying in front of me, so you do not have to. It's for all. Do not have to read the send the comments like so many times. 7 times you are sending. No, you don't have to do that. Just okay. Just you have to uh, do this much. Okay. Now, uh, okay. So it's for all. It's for all. So this is the thing. So potential energy and kinetic energy of simple pendulum. We have seen pendulum. This is the this is extreme position. This is another extreme position, right? Extreme position, extreme position. Okay, extreme position, and this is called mean position. So total energy in extreme position equal to total energy in mean position. Understood? And we'll do some numericals also on that, on the based on this formula. Now, this numerical, whatever we'll do the numerical now, these numericals are not there in the book. But we are doing in the class, all the numericals we are doing in the class. So these are important for your exam. Don't say that these are not in our book, so it's not there. No, since we are doing in the class, so it's there in the syllabus. Understood? It's there. So we'll do few numericals based on this, but here we'll do only one or two numerical now. One or two numerical. Write the first numerical. All of you write the first numerical. The mass of the bob. The mass of the bob of a pendulum. The mass of the bob of a pendulum is 1 kg. The mass of the bob of a pendulum is 1 kg. Okay. Its velocity in mean position. Its velocity in mean position is. Its velocity in mean position is 1 meter per second. Okay. Its velocity in mean position is 1 meter per second. Find its kinetic energy. Find its kinetic energy at mean position. Find its kinetic energy at mean position. Find its kinetic energy at mean position. Okay, we know that in mean position, kinetic energy is there. That is half mv square. Okay, half mv square. So write in this way in the answer. Now you solve it. You solve it like this. At mean position, at mean position, kinetic energy equal to half m. What is the mass? 1 kg. What is the velocity? 1 meter per second. Okay, 1 meter per second. So that is half into 1 into 1. That is half equal 0.5 joule. Okay, this is the sum. All of you solve it. All of you solve it. All of you solve this sum. Okay, so at mean position, kinetic energy is this and this. Okay, now one more sum. Now one more sum for you. Solve it. Last sum, today's last sum. But we'll do more sums in our next classes. But today's last sum, write it. The velocity of a bob is, the velocity of a bob, the velocity of a bob, the velocity of a bob at mean position, the velocity of a bob in mean position is 2 meter per second. Okay, 2 meter per second. Okay, if its mass is, if its mass is 100 gram, if its mass is 100 gram, if its mass is 100 gram, then find its, then find its kinetic energy and potential energy. Kinetic energy and potential energy. Kinetic energy and potential energy at mean position. Kinetic energy and potential energy at mean position. Fine. So what I told you, at mean position, kinetic energy equal to half m v square. What is the mass here? What is the mass of the object? Mass is 100 gram. So mass is 100 gram. You have to convert it into kg. 100 gram you have to convert into kg. So half into 100 by 1000 into velocity. What is the velocity I said? I think 2 meter per second, right? Velocity is 2 meter per second I said. So 2 square. That is Kinetic energy equal to, I'm getting the answer. Anand Garg, again Anand Garg has sent the 4 answers. Anand Garg, huh? One time is enough. One time is enough. Anand Garg, again he is sending this. Anand Garg answer is correct. So this is kinetic energy. The kinetic energy of the simple pendulum, okay, at mean position. Okay, this is kinetic energy of the pendulum at mean position. Okay, those who could not solve it from here. 0.2 joule, this one. Okay, this one. Finish it, all of you. Done. Okay, now so this is the kinetic energy at mean position. Now what is the potential energy at mean position? Write in the comment. Let's see what is the potential energy at mean position. What is the potential energy at mean position? Write in the comment. Let's see. Yes, potential energy at mean position is 0. Correct. Potential energy at mean position is 0. We know that. I told you before. I told you. We have seen. We have written that also. Potential energy at mean position is 0. So here you have to solve kinetic energy is 0.2 joule and potential energy equal to 0. Okay. So we have seen the theory. Theory means total energy of a simple pendulum. Okay, total energy of a simple pendulum at extreme position and mean position. This is mean, that is extreme. Okay, extreme and mean position, we have seen the total energy, kinetic energy and potential energy. And also we saw that total energy at mean position equal to total energy at extreme position. And we have also seen that kinetic energy at mean position equal to potential energy at extreme position. Fine. So we'll do more numericals based on this theory in our next class. Fine. And don't forget, as I told you, that next week, okay, next week you will have your CP. Okay, next week you will have your CP, and whatever we have discussed in the live classes, the same is the syllabus. Now, one thing here, if you follow your book for CP1, if you follow your book for CP1, then gone. Because we have done a lot of extra things which are not there in your book. Okay, so these are required. Understood? These are equally required here. So whatever we discussed in the book, whatever we discussed in the live classes are will be there in the CP. Fine. Now it's the time of attendance. Now I will say start. After that, you will start writing your name. Okay. I'll say start. After that, you'll start writing your name. So student, start. Okay. Yeah, you can write your name in the comment section, then you can leave the class. And those who are writing their name in the comment section means they are present. And just write your name once, that's enough. Anand Mangalam is again writing twice, thrice, not required. One time is enough. Okay. So fine. So this much for today. Okay, this much today. So so next week we'll have CP. Fine. Thank you. Thank you.